All right, so this is a regenerative radio kit by Thames and Cosmos. It's a vacuum tube, single 12AX7 there, and it's a regenerative radio, AM radio, of course. You can put in different antennas to get like shortwave, or you can even make your own to get whatever band you want in the HF band, at least. That's where it does good. Um, this thing has got to be the best learning tool for vacuum tubes and RF stuff I have ever got my hands on. If anyone out there is willing or wanting to learn more about vacuum tubes and radio, would highly recommend getting something like this or buying parts and messing around with it. But this has a nice kind of complete chassis for you and such. This is the insides. The whole thing runs on 12 volts. And you might think, well, vacuum tubes typically run on like 300 volts. How does this work? Well, there are some tubes out there that run just fine on 12 volts, and luckily the 12AU7 is one of them. In fact, there were a whole line of tubes, I think, not a whole line, but a good number that were designed to run on like 90 volts and run fine on 90 volts. And the 12AU7 and the 6DJ8 were examples of that. 12AX7, not so much. You'd have a real hard time getting a lot of amplification out of it, but the 12AU7 seems to function just fine at low voltages. You got your tuning cap here. It's just your old style, just little vanes that like go in and out to change the capacitance there. It's multi-section, but it only uses one section actually. This is the audio transformer for coupling the high impedance of the anode of the tube to the headphone jack, so you can plug in headphones or an amplifier or whatever. And I will show you the schematic and stuff. This regenerative radios are very fascinating to me, at least. So you can make a low gain device like this. This has a gain of like 18 per section. Well, for radio, you need a gain of like a couple thousand, but regeneration, positive feedback, will help with that. So, on to the schematic. All right, so this is the schematic for the 12AU7 regenerative radio that I just showed you in physical form. This is the schematic here. Basically, we got 12AU7. Remember, it's a twin triode tube. There's two triodes in one envelope, and so we're definitely using both here. The input consists of these various antennas that are coupled into an LC tank circuit, and of course the capacitor, the C part of the LC tank, is made variable so that the frequency response could be adjusted. Your tuning, basically. That's coupled in to the grid of this tube. This tube amplifies that signal, and that signal coming in is like tiny. It's like probably microvolts peak to peak, barely detectable by the tube. It comes in, gets amplified, and the cathode is coupled back into the LC tank circuit by a center tap on the coil, and that puts amplified RF energy back into the tank circuit. It re-responds again, goes back into the grid, effectively making a positive feedback loop. This is how a lot of amplification can be achieved, even with a low gain device such as this 12AU7. After the RF energy has achieved suitable amplification, meaning it be amplified but not enough to oscillate, which is why its level is made variable by this feedback knob, controls basically how much this tube amplifies to control how much goes back into the LC tank circuit to overcome its losses. Typically, you want to set this so that it's just on the verge of oscillation, so you get, the maximum RF, maximum output. This goes into the next stage, which is effectively an audio amplifier. This 330 puff cap takes down any remaining RF, because bear in mind this tube is kind of in like a class C mode where it rectifies the incoming RF and demodulates it, And we're just removing all that hash with this capacitor, so all you get is the audio component of that AM signal. And this goes into a 20-to-1 coupling transformer that goes to a headphone socket. Now, say your headphones are 32 ohms, 20-to-1, and of course the impedance being the square of the turns ratio, that'll give you maybe 12, 13K of impedance, which is quite optimal for the 12AU7. I imagine this stage will probably give you around a gain of about maybe 10 or 11 at the least. And of course, it's all powered on a 12-volt battery. And there is a switch in the feedback knob, like when you turn the switch up, it's a switch to knob, so it acts as to turn on the power. Now, these different antenna, the antennas are coupled in to various points in the LC circuit to give different responses. They load it differently. 2 of them go to the center tap, 1 through a capacitor, and the capacitor makes it so that it doesn't load the tank circuit as much. The third antenna 3, loads it the most, but you get more direct coupling. And it's loaded because the antenna has its own capacitance relative to ground. And so depending on your antenna size and what frequency range you're operating in, you select between these 3, and you can really optimize how this thing receives. Of course, you can also chuck in other capacitors in here to fix the band or to widen it or to shorten the band to one's liking. But that is the basic operation of this 12AU7 regenerative radio. So basically, the 12AU7 tube here is it's some Chinese brand, some off-brand, I don't even know what it is, but it works just fine, especially in this application. And the kit came with 2 different antennas. This is the medium wave coil, this picks up the AM broadcast band, and a shortwave coil, which basically does like the whole ham radio band. And that's basically the extent of this thing. It's probably good up to like 60 megahertz and probably no more. So I'm going to go ahead and put on the medium wave and show you what this thing does. Okay, so I've gone and plugged in the medium wave coil. This picks up the AM broadcast band, as I said, and I plugged it into a separate recorder so that you can hear what's going on. Now, I haven't hooked up the ground or any of the antennas yet, and this is just sort of a baseline. So it's on, and as I rotate this cap, I sweep across the band. You can hear as I tune into a station, there's like an oscillation that kind of goes on. And the more I increase this knob, the more pronounced it becomes. And as I back it off, the station comes in and you hear the voice is relatively normal. And of course, depending on the strength of the station, this knob is going to be different so that you don't get oscillation, but this so you still hear the station. And that's that. So now I've gone in and put a ground connection. This is just going to my power supply, and everything on this desk is grounded. So it's grounded now, and this makes a huge difference. Stations that were weak before are now not weak at all.
In the future, stocks closed mixed once again on Wall Street. Dow Jones Industrial Average climbed 9.
So yeah, you get the idea. So when I put an antenna on, I just strung this up on a shelf somewhere. It's probably a couple of yards long, not that long. Again, some improved performance, a lot more stations. You can hear a bit of distortion on that particular station. can hear that perhaps this type of modulation is not exactly perfect for certain things. It's extremely sensitive, but it's not necessarily the highest fidelity. If you messed around with one of these circuits, I think you'd understand that after enough messing around. Okay, so now I got the shortwave antenna hooked up, and I took out the antenna for now. It's weird. It performs better without an antenna sometimes. Depends on where you are and what sort of antenna you have. Depends on the time of day, too. During the day, I find it very hard to pick up any decent stations during the day. It's all just noise for some reason. I don't know how main sum gets coupled into this antenna, but it does. It's with an antenna. And in the evening, you have much better reception, like way better reception. There's kind of a weather system going right now, and I think it's blocking everything. At least in the low frequency range. There's like a little bit of static where a station might be. In fact, oh, there we go. Sometimes you'll get data transmitters that don't actually broadcast voice. And depending on where you move your hand, you'll get different response. It's the weirdest thing. The capacitance of your hands near this thing can actually tune it. Once you get it tuned in, you have to keep your body and your hands around it in a specific way. I've received stations from Taiwan, from totally the other end of the world, with this thing, which just, an antenna probably twice the length of the one I have now in this very room. So this thing's very, very sensitive, and it's capable, but you have to kind of finagle it. But I mean, come on, man, for a 2-section vacuum tube that's not even designed for RF, really. I mean, it can be most tubes can operate in HF anyway, but still, impressive little device. Would highly recommend if you want to learn how to, build these things or learn how to use vacuum tubes or whatever. Start with a simple circuit like this on a breadboard or something. Just get a vacuum tube socket and some wire and just play around with it. Little trick with this thing: if you touch pin 1 and pin 7 at the same time, you get audio feedback because you're moving between pin 1 and pin 7, and just like transistors, the signal here is the same phase as the signal here. And so when you feed that back, when you connect these two, you get positive feedback, hence oscillation. In fact, actually, this oscillation at RF that you hear is actually broadcast back into the RF band. So these things actually, the regenerative receivers will function as transmitters, actually. You can hear this. If you put an AM radio next to it and tune around, you'll hear this thing, just as you hear it through the headphones, believe it or not. Which is probably why you don't see an awful lot of these around, because, I bet the FCC would clamp down on that kind of thing outside of just domestic use like this. And as you can see, this wiring in here really lends itself to pretty much no more than HF, high frequency, because anything above that, the capacitance between these, the inductance, is just going to totally ruin any kind of gain at frequencies higher than about 60 megahertz or so. The skin effect, the voltage standing wave ratio, like mismatched impedances cause wave reflections, that kind of thing. It gets real hairy, and you kind of got to do everything really tiny. Of course, there are tubes designed for VHF up to probably 300 megahertz or so, but that's a whole other video, whole other thing. But yeah, hope you found this helpful.